so we're going to close out chapter 10 by discussing energy changes in chemical reactions. So, in all chemical reactions, we either have the absorption or the release of energy, right? That is pretty much without exception. In fact, I think there are probably a few exceptions, but for the most part, one of the things that makes a reaction is the fact that we have, as the reaction progresses, either an absorption or production of energy. And this is just pointing to a few sources of energy release. Few examples: storage batteries, right? Whenever you have a battery performing its function by providing energy, to a device, basically what's happening is that there's a chemical reaction taking place within the batteries that produces energy. Light stick is another example of a device which produces energy as a result of a chemical reaction. Whenever we have the burning of any fuel where heat and light is produced, that is also an example of a reaction that produces energy. And finally, there are chemical reactions that takes place within our cells in our body which produces energy, and that's another example of chemical changes that produces energy. And then, here we have a picture of a light stick. We all know what that looks like, produces energy, and the next slide shows you a series of chemical reactions which actually results in energy being formed. So basically you have this compound here which reacts with hydrogen peroxide, which produces these two products. This product is very unstable, and what that does is that it reacts with a dye to form carbon dioxide and a more energized version of the dye, so therefore energy is transferred to the dye, and then the dye, being very unstable itself, will simply lose energy. So this HV that you see here actually represents energy being lost, right? So that's basically how the light stick works. Now you have some other examples of reactions where energy is absorbed. So for example, in the electroplating of metals or the decomposition of water into hydrogen and oxygen. In those two examples, basically electrical energy is needed in order for this reaction or these changes to take place. And then finally here, where we have the photosynthesis, where carbon dioxide and water is used to form starch. That also involves the absorption of energy. In this case, it's the absorption of light energy by the chlorophyll, which is the green stuff which you'll find in the leaves of plants. That results in the formation of glucose, which plants use to form starch, basically. All right. So whenever you have a transformation taking place, in other words, a chemical reaction, energy is either absorbed or produced. All right. So that's basically what happens. Now, if you have a situation where energy is absorbed, then the products will have more chemical energy compared to the reactants. But if you have energy that is produced in a chemical reaction, then the products will have less energy compared to the reactants. So that is illustrated by this diagram right here. Well, two diagrams actually. The first one is where you have water being electrolyzed or decomposed by electricity to form hydrogen and oxygen. Energy is required, so therefore what you'll find is that the energy of the products, which would be hydrogen and oxygen, would be greater than the energy of the reactant, which is water. On the other hand, if you have a reaction where hydrogen is reacting with oxygen to form water, energy is lost. So therefore, as you can see here, the energy of the hydrogen and oxygen is higher compared to the energy of the water, which is low. All right, so in both cases, what you'll see is that the hydrogen and oxygen will have a higher energy, higher potential energy compared to water. So therefore, water is more stable compared to the individual elements that make up water. All right. Okay, so that's basically the end of chapter 10. So the next chapter we'll be looking at is chapter 13. So we'll be jumping chapters 11 and 12 to go to 13, which deals with gases. All right.